Okay, hello class. So I'm Dave Schwartz, and this is Math 1430. We're doing section 3.6, implicit differentiation. So we're going to find the derivative dy dx implicitly. So when I say implicitly, that means notice this equation right here. We want to find dy dx for this equation. But good luck trying to solve for y, because this term has a y, this term here has a y squared. You really can't solve this for y, getting y on one side and everything else on the other side without a single y. So because we really can't solve this for y, we're going to find dy dx by implicit differentiation. So here's what we're going to do. We're just going to go term by term because the derivative of a difference is the difference of the derivatives. So I'm going to take the derivative of this side with respect to x, So I'd like to do this as my first step. Let's find d dx, the derivative with respect of this left-hand side, x squared y squared minus xy. And that's going to equal d dx. This is just derivative notation, the derivative with respect to x, for the right-hand side. Okay, and now to take the derivative, we're going to go the derivative of this term minus the derivative of this term. Notice this first term is a product, so we're going to need the product rule here. So I'm going to use the product rule to find the derivative of the first term. It's going to be the first, which is x squared, times the derivative of y squared. What's the derivative of y squared? Well, by the power rule, it's going to be 2y. But because y is some function of x that we couldn't solve for, we're going to say the derivative of y with respect to x is just dy dx. You could write y prime, same thing. So it's up to you. Either write dy dx or y prime. So still continuing with the product rule. I just did the first times the derivative of the second. Then it's going to be plus the second. The second, exactly as it appears, is y squared times the derivative of the first. Well, the derivative of x squared with respect to x by the power rule is just 2x. Okay, minus, we're done with that first term, and now here we have another product. So let's use the product rule. So it's going to be the first, which is x, times the derivative of the second. What's the derivative of y with respect to x? So just imagine that y is some function of x. So what's the derivative of y with respect to x? Well, the derivative of y is just 1, which you don't have to write, times dy dx. So I'm just going to write dy dx, but you could write 1 times dy dx. Okay, so there's the first times the derivative of the second, plus, oh, be careful with this minus sign. Be careful with this minus sign. So when I want to go minus this derivative, you write down the minus, and then you must use parentheses, because this derivative is going to be a little bit involved. So you must have those parentheses. So it's going to be minus, and now by the product rule, it's going to be the first times the derivative of the second plus the second times the derivative of the first. The derivative of x with respect to x is just 1. That you don't have to even write that 1 if you don't want to. Okay, and then we're done with the product rule there, and that's going to equal, for the right-hand side, what's the derivative of any constant or number? 0. Okay, so now we just want to simplify this. This first term right here, it looks better if you put the number in front. So I'm going to write 2x squared y dy dx. So that takes care of this first term, and simplified. Plus, and now this second term, that looks a little awkward to me. Put the number first, the coefficient. So 2xy squared. I like my variables in alphabetical order, but you don't have to. Okay, now we're going to clear these parentheses by distributing the minus. For minus x dy dx, and then y times 1 is y, but what's minus a plus y? Minus y, and that's going to equal 0. And now, here's the rule. You want your dy dx terms on the same side. There's a dy dx term, there's a dy dx term. So write them on one side, 2x squared dy dx, minus x dy dx, and that's going to equal, and then you bring these two terms to the other side of the equal sign. So when you subtract 2xy squared to each side, you're going to get a negative 2xy squared, and when I add y, this is a minus y here. So when I go plus y to each side, I'm going to write plus y. And now, remember, I want to find dy dx. I want to find that derivative. So to get dy dx by itself here, here's the key step. Key is doing this, factoring out the dy dx from both of these terms on the left-hand side to isolate. So I get 2x squared y minus x, and that's going to equal the negative 2xy squared plus y. And now to get dy dx by itself, and by the way, we're going to have another step after this. You're going to see in a second. When I get dy dx by itself, I divide by this factor here to each side. So it looks like at first glance that divide by the 2x squared y minus x. It looks like that's the final answer, but hold the phone. Notice I can pull out a y from that numerator. I'm going to pull out this negative in front too. So I'm going to pull out a negative y from the numerator. And the reason why I'm doing this is we're going to get a cancellation here. So had you left this as your final answer, at most I would take off 1 point. This is 99% good. So if I pull out a negative y from these two terms, I'm going to be left with a 2xy. And then, because this says a plus and I pulled out a minus, you got to write minus, because minus a minus is a plus. And then we're going to write 1 here. And then as a quick check, if I distribute this negative y, do I get that numerator? Hell yeah. And that's going to be over. And now with my denominator, I have x's in both terms. So if I pull out an x, I'm left with 2xy minus 1. And as promised, we get canceling. 2x minus 1 over 2xy minus 1. They cancel out. They become 1s. So my final answer is negative y over x. So that is what our dy dx is. And we are done. So good night, everyone.